You know, back in 2014, the movie Interstellar just blew our minds. It took us on this incredible ride through space and got millions of us thinking about wormholes, distant planets, and, well, the biggest, baddest thing in the universe, the black hole. So today, we're going to unravel all of that. We're going to separate the Hollywood magic from the incredible scientific reality.
I mean, that climax of the movie is just unforgettable, right? The main character, Cooper, literally pilots his ship right into this monster black hole they call Gargantua. And after he ejects, he doesn't get crushed, he ends up in this, this strange five-dimensional library of time. It was an amazing scene, and it left all of us asking one gigantic question.
So, yeah, could any of that happen? What does science actually have to say about taking a trip into one of these cosmic behemoths? That's exactly what we're going to figure out right now.
Okay, so before we can even begin to answer that massive question from the movie, we really have to get on the same page about what a black hole even is. This is the textbook definition, but let's break it down. A black hole isn't really a hole like you dig in the ground, it's an object. An unbelievably dense object with a gravitational pull so powerful that it creates a one-way street. Anything that gets too close gets pulled in, and nothing, not a planet, not a star, not even light itself, can get back out. And that's why it's black.
So the whole story of black holes, it really gets started over 100 years ago with, you guessed it, Albert Einstein. Now, he never actually found one, but his completely revolutionary ideas about the universe basically wrote the rule book for their existence. And you can see how the idea evolved. First, in 1905, Einstein tells us that the faster you move, the slower time passes for you. Okay, mind-bending enough. But then, 10 years later, he drops an even bigger bomb. Gravity does the exact same thing. It's pretty wild to think that even after that, it took another 50 years before somebody came up with the perfect name for it, the black hole. This right here, this is the science behind that incredible scene in Interstellar. Remember that planet they visit where 1 hour for them was 7 years back on the ship? Well, that wasn't just some clever plot device. That was real science. It's called gravitational time dilation, and it was happening because they were so close to the immense gravity of the black hole. The takeaway is simple, and it's profound. Gravity literally bends time. To help us wrap our heads around this, Einstein came up with this brilliant analogy. Picture space and time woven together into a single, giant, stretchy sheet, like a trampoline. Now, if you put a bowling ball on it, it creates a dip, right? That's like a planet. A bigger, heavier ball, like a star, makes a bigger dip. But a black hole? That's like putting something so heavy on the trampoline that it just rips a hole straight through. It creates a pit so deep that once you fall in, there is no way to climb back out.
So if black holes are a real thing, where in the universe do they come from? Well, the answer lies in the incredibly violent death of the biggest stars out there.
You can think of a star's entire life as this epic cosmic battle. For billions of years, you have the explosive energy of nuclear fusion pushing everything outward, while the star's own immense gravity is trying to crush everything inward. It's a perfect balance. But eventually, the star runs out of fuel. The outward push just stops, and gravity wins. It wins in the most spectacular fashion you can imagine, causing the star to collapse and then explode in what we call a supernova. And what's left behind? The tiny, crushed, ultra-dense corpse of the star, a brand new black hole. But not every star gets this dramatic ending. Turns out, there's a magic number, a threshold discovered by an astrophysicist named Subrahmanyan Chandrasekhar. It's called the Chandrasekhar limit, and it tells us that the core left over after a star dies has to be at least 1.4 times the mass of our own sun to have enough gravitational muscle to collapse into a black hole. Our sun, by the way, isn't nearly big enough, so we don't have to worry about that happening here. And it turns out, black holes come in a few different sizes. You've got your stellar black holes, which are born from the collapse of a single star. But then you have the supermassive ones. These are the true monsters of the universe, weighing more than 1 million, sometimes billions of suns. And we think there's one of these giants at the center of almost every big galaxy, including our own Milky Way. Ours is called Sagittarius A star. All right, so what would we actually see if we could fly up to one of these things? Let's take a tour, from the outside in. The very first thing you'd notice is this stunning, brilliant ring of light. But here's the key. This light isn't the black hole itself. This is what's called the accretion disk.
It's basically a chaotic whirlpool of gas, dust, and any other debris that's gotten trapped by the black hole's gravity. All that stuff is spinning around at nearly the speed of light, which heats it up to millions of degrees and makes it glow like you wouldn't believe.
And this is where Interstellar got so much right, but also took a little artistic license. The movie gave us this fiery orange-yellow ring because, well, it looks amazing. In reality, that disk is so hot it mostly emits X-rays, which our eyes can't see. And notice this other cool detail. One side of the ring is actually brighter than the other. That's because the stuff spinning towards us gets a boost of brightness, an effect called Doppler beaming. Pretty cool, huh?
Okay, so if we push past that glowing, chaotic disk, we finally reach it. The event horizon. Now, this isn't a solid surface you can touch. It's a threshold. It's an invisible line in space that marks the point of no return. It's the exact spot where the gravitational pull becomes so powerful that the speed you'd need to escape is faster than the speed of light. And since nothing can go faster than light, once you cross it, there is absolutely, positively no coming back.
And then, at the very, very center of it all, we have the singularity. This is it. This is the place where all of Einstein's brilliant theories, all the physics that we use to understand the universe, they completely break down. It's a single point of theoretically infinite density, where our entire understanding of space and time just collapses. We honestly have no idea what it's truly like.
So, with all that in mind, let's circle back. Let's put it all together and finally answer our original question from Interstellar, separating the science fiction from the incredible science fact.
Okay, first myth. Black holes are not cosmic vacuum cleaners, just sucking up everything in the galaxy. They're actually more like galactic anchors. They follow the rules of gravity just like our sun does. And what about surviving the fall? Well, sorry to disappoint, but you wouldn't find a time-traveling library. You'd experience something scientists colorfully call spaghettification, where the tidal forces would stretch you thinner and thinner like a noodle until you were torn apart. So that Tesseract, it was a beautiful, brilliant idea for a movie, but it's pure speculation. The honest truth is, we have absolutely no idea what's on the other side of that event horizon.
And you have to remember, for the longest time, everything we've talked about was just theory. It was all just math on a chalkboard. But then, in 2019, the Event Horizon Telescope project gave us this, the first ever direct image of a black hole's shadow. It's this blurry, glowing donut of light, and it proved that Einstein's wild, warped idea of reality was, in fact, reality. Just an absolutely incredible human achievement.
Which leaves us right here with the ultimate question. That singularity represents the absolute edge of human knowledge. So what is it? Is it a gateway? Does it hold the secrets to a whole new kind of physics that we can't even begin to comprehend? Or is it just the end of the line? A final cosmic dead end in the fabric of space-time? For now, we simply don't know. And maybe that's the most exciting part of all.